In this video, we're going to go over a few relatively simple examples that make use of the derivative rules for log and exponential functions. So the rules that we use are written here. The first one is the derivative of the natural log function equals 1 over x. The second is that the derivative of b to the x equals b to the x times natural log of b. And here b is a positive number that's not equal to 1. And then finally, the derivative of log base b of x, once again b being a positive number not equal to 1, the derivative of log base b of x equals 1 over x times the natural log of b. Okay, so we want to use these rules to do a few simple examples. The first one we're going to do is the derivative with respect to x of the natural log of 3x. So I have written out to the side here the basic rule that this problem kind of goes along with. So I have the natural log of 3x, but it's still of the form natural log of x, except instead of having just x inside the natural log, I have a function of x inside the natural log. So that suggests that I'm going to have to use a chain rule to solve this problem. Okay, so remember when the chain rule says that whenever you have an outer function and an inner function, the derivative is the derivative of the outer function, keeping the inner function in there, times the derivative of the inner function. So let me show you what I mean. Okay, so we start by taking the derivative of the outer function. And we know that the derivative of the natural log of x is 1 over x. But I want to keep my inner function in there, so it's 1 over 3x. Okay, so just 1 over what's ever inside the natural log. But the chain rule says that I should multiply by the derivative of the inner function. So here I need to multiply by the derivative of 3x. And the derivative of 3x is just 3. So this is 3 over 3x, or 1 over x. Okay, so what we did there is we just did 1 over the inside of the natural log times the derivative of what's on the inside. And that's how to use a chain rule when you're taking the derivative of the natural log of something. Now there's also another way you could look at this problem if you wanted to. And either one of these ways of looking at it is the same. You could go ahead and use some of the rules for the natural logs to rewrite this. So I can rewrite the natural log of 3x as a natural log of 3 plus a natural log of x. And then you'll see that I get the same answer as I did in this first line because the natural log of 3 is just a constant, so its derivative is 0. And then, of course, the derivative of ln x is 1 over x. So whichever way you want to approach the problem is fine. Okay, so let's do a different one. So let's do this one. The derivative with respect to x of 3 to the 5x. Okay, so what's the basic rule I'm going to want to use here? If I look back, this is the second rule here, b to the x. I'm going to want to use this rule here. So let me write that out to the side. The derivative of b to the x equals b to the x natural log of b. Okay, so why did I know that I had to use this rule? So this rule is for when you have a base, b, some number, raised to x as the exponent. And here I've got that basic form. I have a number, 3, raised to an exponent that involves an x. So I want to use this form, this rule. But once again, my exponent is not just x, it's 5x. So I'm just going to have to use a chain rule in addition to the basic rule. Okay, so I always want to start by taking the derivative of the outer function. Okay, so the rule says that I keep the 3 to the 5x, multiply it by the natural log of the base, which in this case is 3, so times ln 3, times the derivative of the inner function. Okay, and for clarity, I'm just going to write out this step here. So the derivative of the inner function, which in this case is 5x. Okay, So this is 3 to the 5x times natural log of 3 times the derivative of 5x, which is 5. Okay, so it might be a little bit confusing seeing the chain rule applied in this new context. But basically what I have is if you want to think of it as 3 to the f of x, where f of x in this case is 5x. And remember, the chain rule says that I start by taking the derivative of the outer function. So 3 to the x in this case. So if I take the derivative, so that's going to get me 3 to the f of x times ln 3, but then I multiply by the derivative of f of x. Okay, so I just wanted to maybe clarify if that was a little confusing how the chain rule worked in this situation. But anyway, here we are at our answer. 3 to the 5x times natural log of 3 times 5. And I want to caution you about a mistake that's really easy to make in this situation. So you might be tempted to write this as 15 to the 5x times ln 3, but that's no good. The 5 does not have an exponent. The 3 does have an exponent, so we can't combine them through multiplication. So you would just want to leave this in this form. You can write it in any order that you want, but you can't combine that 5 and the 3 by multiplication. Okay, so let's look at one more problem very quickly. So here we have the derivative of log base 7 of the quantity 5x plus 2. So which rule does this form kind of match the best? Well, this last rule, right? The log of some base of some function of x. And here we have log base 7 of 5x plus 2. So my rule for the derivative of log base b of x is 1 over x natural log of b. Now, as it was in the previous examples, it also is here. I don't just have an x inside the log, I have a function of x. So I'm just going to have to use a chain rule and tack on the derivative of that inner function. Okay, but this derivative, if I use the form here, 1 over x ln b, but it's going to be 1 over 5x plus 2, 1 over my inner function. So 1 over 5x plus 2 times natural log of my base, which in this case is 7, times, now that whole thing I need to multiply by the derivative of the inner function. So my inner function in this case is 5x plus 2, so its derivative is 5. Okay, so I can write this as 5 over natural log of 7 times the quantity 5x plus 2. And that is my final answer.